If you work with unstructured data or semi-structured data, you know how painful it can be. There's a lot that we can do to structure it for AI systems on top, but I don't believe that they actually go far enough to do real enterprise analytics. To aid the agents on top, there are two architectural decisions that we typically make. The first one is just structuring it for the agent. So you'll see things like Dockling, landing AI. There are even applications like unstructured I/O that allow you to actually parse and extract what's inside of a document or a PDF. So the first thing is we want to structure it. The second thing that we typically focus on is more on retrieval. So we could have very heavy retrieval operations. There's something called doc ETL, and essentially how are we going to construct all of the operations that we want to do to actually go in and retrieve something in a bunch of data. We also might even just focus on how we store it then. So if we're doing all this work to structure the data, we store it in a way such as like a graph database, and we want to do graph rag. Um, but overall, it typically involves us doing a lot of pre-processing and structuring the data, and then we end up kind of losing that structure when we put it into an embedding model because we need to do retrieval over it. So we do a lot of upfront work to structure, and then we kind of lose that structure when we are so focused on retrieval. So there's the pre, and then there's the storage, and we kind of hope that these two worlds meet together. But I don't necessarily think, and we've been doing a lot of thinking here, that doesn't go far enough to support real world analytics workflows, especially when you're in an enterprise and there's going to be decisions that are going to be made. The real reason that we believe this is because at the atomic level, you're still typically just working with a wall of text. So even if I were to parse a document and extract all of the notes columns from a document, at the atomic level, like within that cell in the database, there's still just a wall of text that an LLM has to reason over. Snowflake and BigQuery have tried to combat this with a couple of functions, these inline LLM calls within SQL. Um, AI complete and AI generate. These are row level LLM completion functions that essentially call the LLM within SQL and allows you to tag the data at the row. So that way we're going within this wall of text and at least trying to extract something out. There is another one, or actually two more, that are AI ag, AI underscore ag for Snowflake or AI dot ag for BigQuery. These are more so built to summarize the entirety of the set. So instead of tagging at the individual level, what they're trying to propose is, say you have a bunch of reviews in a specific column, how can you summarize and get the main thematic insights from all of those reviews? What these specific functions do is essentially batch all the individual rows, and then they summarize it, and then they do the same thing in almost like a game of telephone. So I'm going to batch, batch, summarize, and kind of iterate, and then they summarize the summaries. So there's like a meta analysis that's being built all the way down the set, and that actually helps you get past some context window issues. Two problems typically arise though. So what happens if we just refresh? If we rerun the data, are all of those meta summaries and that final string output, are they going to be the exact same? Probably not. It's a completely non-deterministic, kind of lossy game of telephone that's happening across this entire set of data. So if we rerun, we're going to get a completely different analysis. And if we're doing analytics, that doesn't make sense. If I refresh a dashboard that shows me revenue, I'd expect those numbers to look the exact same as I just did 10 seconds ago. And going back to extracting themes, what happens if I am extracting themes? If I'm tagging every single individual row, I just am left with millions of very similar but different tags. And now I have to reconcile that downstream in another lossy operation. So one row might say price, the other one might say pricing, another row might say cost. And now it's up to me to do another downstream operation. If I have billions of rows, I have a billion different iterations of somewhat similar words. So It's another issue that I now have to reconcile downstream. So what can we do? We've been thinking about this a lot, and an idea that we have is, what if we take the entire column and we remove it? And then we create or multiple series of columns. We take them, we remove them, and then create entirely new dimension tables that we can do inspectable and interpretable work on. So for example, if we take this entire column and cluster it, let's just use the reviews, for example. We take the entire the entire column of reviews, we make it its own thing, we cluster that, you maintain the document IDs because all the documents then get aggregated into these clusters. And then what you can do is just join it back to the source table. The reason why we like doing this is clustering at least gives us a set of parameters that we can work with. We can inspect the inter and intra-cluster distances. We have an understanding of the density of each of these clusters, but then they actually maintain all of their citations. They're just naturally aggregate functions, and we can isolate it and then join it back to that original source table. And then also when we refresh, we now kind of have an understanding of, will we get the exact same answers or the exact same documents out? And typically it's extremely close. You can at least inspect why you did or didn't. And typically what happens is when you refresh those clusters, maybe the documents are the same, but the LLM labeling step is actually the thing that changes. So that's something that you can at least inspect now. You can at least understand, okay, I did rerun this pipeline, or I did, redid the clustering operation. The documents are actually the same, but typically you apply an LLM that labels that cluster of documents, and that changes periodically. But at least now you know the data set is the same, but it's how you're labeling that data which is changing, and you at least have some sort of a managed taxonomy that you understand clearly. It still suffers from the same issues at times, such as we want to bring in new data. That's always really hard. But the beauty is that there's at least streaming clustering algorithms that you can use. And you understand what they're doing in terms of, are they, fitting a document into an existing cluster? Are they kind of holding it and waiting to see if enough proof kind of flows in to where it needs to create its own cluster, and then merging and hierarchy. At least all this stuff is explainable when you isolate it and use different models outside of large language models. The beauty of this too is now all of our decisions are in code and they can be versioned. We can go back in history and see what we changed, and we're not necessarily finicking around with prompts. So yeah, you can save different variations of prompts and like see how they work with the data, or you can use different models and different algorithms that have these explainability metrics already baked in. It's directly into your versioning process already, and you don't really have to change what you're doing. Overall, the beauty of this is that now it creates somewhat of like a semantic materialized view, to where when you refresh the rest of the query alongside joining back this new dimension, you're going to get the same answer. So if you when you isolate it, you join it back to the table, you rerun the query, and now you get the same thing. You get the exact same table. You've essentially created, you've taken the fuzzy semantics out of the equation, and we're back to just working with relational databases. And this is a lot more comfortable as an analyst because you actually understand what's going on. You can refresh the dashboards, you can refresh your queries. Everything is much more materialized and much more managed in a way that you can actually explain why numbers are changing. So yeah, in summary, we do a lot up front, which is great to pre-process and structure our unstructured data. We lose a lot of that though when we throw it into an embedding model and then focus on retrieval. We believe that there's this missing middle step, or this kind of gap of how we're transforming it in a way that we can actually understand for reporting. This is something that we're working on internally, and this is how we essentially view different ways to create real world applications or enterprise analytics in this fuzzy semantic space.